సుబ్రహ్మణ్యం ఒక 10 minutes వస్తాను, నేను మీటింగ్లో ఉన్నాను. ఓకే, కూర్చోబెట్టండి. ఓకే,
shall we start, sir? A very warm good afternoon to one and all. Welcome to 1 week online international faculty development program on advancements in automobile engineering for sustainable development during 24th June to 28th June 2024. And there is overwhelming responses from across India and abroad. Around 400 registrations has came, and thank you all for joining international faculty development program. I welcome Dr. T. Srinivas Rao Garu, Head of the Department, Automobile Engineering, VNR VJIT. Thank you, sir, for joining us. I welcome Dr. Channakeswara Rao Garu, Director for Advancement and Dean Admin, VNR VJIT. Thank you, sir, for joining us. I welcome Dr. A. Subhananda Rao Garu, Director, Research and Development, VNR VJIT. Thank you, sir, for joining us. I welcome Dr. Aslam Ansari, sir, former Executive Director, APS RTC, and now he is associated with Automobile Engineering, VNR VJIT. Thank you, sir, for joining us. To start the proceedings, let me invite our Head of the Department, Department of Automobile Engineering, to address the gathering.
Good afternoon, one and all. So I welcome all the participants, guests, and keynote speaker for this inaugural session on FDP on advancements in automobile engineering for sustainable development. So I thank the resource persons, Dr. K.C. Vora, Professor of Practice and former Senior Deputy Director at Automotive Research Association of India, Pune, Dr. Sitarameshwar Sharma, Senior Vice President, Mahindra & Mahindra, Chennai, Dr. Rajalakshmi, Director, TIHAN stands for Technical Innovation Hub on Autonomous Navigation and Data Acquisition Systems, and Professor at IIT Hyderabad. Dr. Dhole, Head, Safety and Amalgamation, Central Institute of Road Transport, Pune. Dr. Satish, Technical Manager, Ford Research and Innovation Center at USA. Dr. Naga Srinivasalu, Professor of Mechanical Engineering at NIT Warangal. Dr. Prasad, VNR VJIT, and Director Channakeswara Rao Garu, Dr. Subhananda Rao Garu, Dr. Ansari Garu. So thank you for joining us, all of you. So today's topic, advancements in automobile engineering for sustainable development, is very relevant to the present scenario. Government of India has come up with FAME, fast adoption and manufacturing of electric and hybrid automotives, with 10,000 crores of rupees. So this topic is going to cover some of the SDGs, Sustainable Development Goals, declared by United Nations. So these goals are sustainable cities and communities and climate action. So this FDP, International FDP, is going to cover such topics during these 5 days, advancements in automobile engineering for sustainable development. Thank you one and all for joining this inaugural session.
Thank you, sir. Now I invite Dr. Channakeswara Rao Garu, Director and Dean Administration, to address the gathering.
Good afternoon to all of you. Namaskar, Swagatam, Suswagatam to all of you for this 1 week online international faculty development program on advancements in automobile engineering for sustainable development. So on behalf of VNR VJT, on my own behalf, I would like to express my heartfelt gratitude to all the members who have joined in this particular workshop, and also delegates from various institutions, and my dear colleagues who are there on this dais. So on behalf of Department of Automobile especially, so every year we used to conduct this type of faculty development program during the summer vacation to improve the skills of each and every faculty and as well the students also. So in this connection, we have proposed to this August gathering to conduct this type of faculty development program, because the faculty development program will help you to improve the skills that are required by the industry 4.0. As for the VNR VJIT is concerned, so this college is one of the most sought after college in the state of Telangana, and recently the institution has got an NAAC accreditation A++ with a CGPA of 3.68 score. out of 4 scale. So in this connection, so I would like to request all the experts who have joined in this particular workshop. So please try to interact with all the people and try to acquire the knowledge that is required by the industry. So today, I think everybody is talking about emerging technologies, how we are going to implement emerging technologies in automobile engineering, especially AI, machine learning, and IoT technologies and sensor technologies, how we are going to make use of to improve the efficiency of automobile, there is a cars as well as the 2-wheelers or 3-wheelers. So as far VNR VJET is concerned, we are also giving top importance for the battery management system also. So there I think EEE department is conducting a lot of research in this particular area, and that way I think our faculty, I think they have already enriched with battery management systems also. So I request all, especially the speakers who are going to deliver the lectures, please focus on battery management system, AI, machine learning, IoT, cyber security also, because nowadays security is also very, very important. So that way I think each one of you should focus on these areas. And the most important one is the material and sustainability, how we are going to make use of the green energy to improve the efficiency of the engine. So that way I think so this 1 week faculty development will help you to improve the knowledge in these areas. I request so the department, so please try to focus research on these areas, and those who are pursuing PhD, please try to acquire the knowledge that is required, because CFD is one of the most important topic. I think nowadays everybody is talking about only CFD, how to improve the efficiency of the engine. And we are also going to implement a hybrid technology also, because recently we got one project under SURE scheme from DSTE. So that project also I think they are going to demonstrate in this particular 1 week. So how the technology is going to be revolutioning automobile engineering, because nowadays I think the students, they are not opting automobile engineering. So that is the reason, that's why recently we have changed the curriculum and we have implemented almost all new technologies like IoT, embedded systems. So these are all the new technologies which we have already included in the curriculum. So that way I think definitely year after, I think there is a huge scope is there for the automobile engineering also. So especially the faculty, I think you have to motivate the students to join this course. And because nowadays I think everybody is talking about the how to improve the smart, that is the EV also, because by 2030 I think there is a 30% of demand will be there in EV. So that way I think please all of you focus on this EV also. So definitely I think with these technologies we can enrich knowledge in this particular area, and that if we can transfer to the students, so that we can motivate the student to join this automobile engineering. So thank you once again. I hope, I think you are going to enjoy this 1 week. At the end of the day, definitely you are going to learn many technologies so that you can implement at your endeavor. Okay, I wish you all good luck. Thank you once again. All the best.
Thank you, sir. Now I invite Dr. A. Shubhanand Rao, sir, Director, Research and Development, to address the gathering.
Good afternoon, everybody. Director Chanakesrao Garu, Dr. Srinivasarao Garu, Ansari Garu, dignitaries, resource persons, delegates, faculty, and students. At the outset, I congratulate Department of Automobile Engineering for conducting this international FDP. This is not national, international FDP on advancements in automobile engineering for sustainable development. So if you talk about sustainability in automobile field, what we talk is zero emission vehicles, that is number one. Number two is carbon neutral manufacturing. One is the vehicles, other one is the manufacturing. How do you do the manufacturing? So if you look now, there is a growing demand for electrical vehicles. Why this demand is there? This demand is there because petrol prices have gone up for a cost reduction. That is one of the reasons. Second reason is the public, the consumers, society, they are much aware of the environment, environmental issues and all. And they are also thinking of sustainability because of the news that is spreading around, mostly on greenhouse gases, carbon neutrality, everything. Now the people have become more aware of these environmental issues, and they want to buy, they want to contribute in this area to the society. So these are the two reasons why we are going for this electric vehicle now. So a lot of advancements are taking place in automobile engineering, leading to revolutionary mobility solutions, including electrical vehicles, fuel cell vehicles, autonomous vehicles, connected vehicles using IoT, materials, new materials, manufacturing processes, use of recycled materials, and extensive use of 3D printing in manufacturing complex and customized components. So many advances are taking place in the field of automobile engineering. So when you talk about zero emission vehicles, there are three options. One is a battery driven car, as all of you know, then fuel cell driven cars, and hydrogen combustion engines. These are the three options available for zero emission. Now, if you take battery driven cars, the lithium ion batteries, they are being used extensively now in almost all the electric vehicles. What are the problems now we are facing is the fast charging requirements, because charging takes a lot of time. Fast charging and safety are the two critical issues. So our institute is working on the fast charging. Our electrical engineering department is involved. They have made some hardware also and demonstrated fast charging. So we will be working more on this, and we will be able to contribute in the field of fast charging. In the whole, all over the world, if you see, advanced research is going on to replace lithium-ion batteries. Yes, this cost is very high. This lithium-ion battery cost is very high, and its life is 2 to 3 years or 300 to 500 charging cycles. So naturally, there is a demand and there is a requirement to have the battery at the affordable cost, to bring down the cost of the electrical vehicle, because battery cost is the most dominating in the total cost of the car. So work is going on to replace the lithium with sodium and aluminum. All over the world, this work is going on. If you talk about aluminum ion batteries, they are very of low cost because the aluminum is cheaper, low flammability, that is from the safety point of view, easy handling, etc. These are the obvious advantages. But there are challenges also with respect to selection of anode material and relatively short life they have got. So most of the work that is being done has not culminated into development of a usable aluminum ion battery, and there is a lot of work to be done, and we look forward for this aluminum ion battery. Other one is the sodium ion battery. Sodium ion battery has come to a stage where it can be deployed. In ARCI is one institute in Hyderabad. They are also developing this sodium ion battery, and it has come to a stage where it can be used. But the problem here is with sodium ion, it is a low energy density, which means it is storing less energy in the given volume and given weight. So right now they are not suitable for automobiles, and they are very much suitable for stationary applications. So we look for the future for the sodium ion batteries also, where they can be deployed in the automobiles. Next, let us talk about the fuel cell vehicles. These fuel cells powered by hydrogen have emerged as a promising alternative, as all of you know, because the advantages are this is a clean system, efficient system, high performance system, and stable power source, highly reliable, and high safety. These are the main advantages of the fuel cell vehicle powered by hydrogen. So, but if you see the energy conversion efficiency of the fuel cell, it is very high. It is of the order of 62%. The overall efficiency, when you talk about tank to wheel, it is 37.7%, which is almost double that an IC engine can give. So that is the main advantage. The thermal efficiency is very high for the fuel cell. No vehicle emission other than water vapor, because H2 is being used. Only water vapor is there in the emission. And H2 is abundant, and now people are talking about green hydrogen. Green hydrogen means for sustainability, we are going to use they are using the renewable energy by electrolysis of water for production of the green hydrogen. So even our Honorable Prime Minister has started National Green Hydrogen Mission to make India a global hub for production and usage. We set the targets by 2030 to bring 8 lakh crore investment, 8 lakh crore Indian rupees investment, and create 6 lakh jobs in this during this 5-6 years. And scheme also offers an incentive of 50 rupees per kg in first year, 40 rupees per kg in second year, 30 rupees per kg in third year. So that is how the incentives are being given, and the production is projected as 5 million metric tons per annum. So that is why many companies like Advani, Adani, GAIL, Reliance, Indian Oil, L&T, BP, NTPC, ONGC, many people are working on green hydrogen. But you can see what are the cars that are running with fuel cell. One is the Toyota Mirai. Toyota Mirai is the very popular thing run by fuel cell. And Hyundai iX35 and one Nexo also is there. So maybe many more, I do not know. I just came to know these three. So if you talk about fuel cell, these are very few cars that are available. But if you talk about battery-driven vehicles, there are many brands available. So why it is so, we'll just come to a little later. The third category is the zero emissions, is the hydrogen combustion engine that is more suitable for trucks. So normally it is being that Volvo is developing this, developed already the truck with the hydrogen combustion engine. And this is being used. But you have to see the cars that use this engine, that hydrogen combustion engine. But that also may come in the future. Many people must be working on that. So now, what is the main disadvantage of this hydrogen? The hydrogen is required to be stored because it is very light metal. It is required to be stored very high pressure. At very high pressure means 350 to almost 700 bar it goes in a composite mode, composite tanks. So this is one main disadvantage. But the people are using it. Whoever is using this fuel cell in this top three bands, they are using up to 700 bar composite tanks for storing the hydrogen. And the other problem is the filling stations. The filling stations should be available for hydrogen filling. So these are the two limitations. But you can see that in future, the fuel cell run vehicles also will be more on the road. If you talk about the carbon footprint, reported values are electrical vehicles are giving 2.7 grams of CO2 per kilometer, where fuel cell car is 20.9 grams of CO2 per kilometer, because the production of the sustainability, when you talk about, it comes to the production. There is the production of the battery, it is the production of the hydrogen. So these things, if you consider, these are the values. But if you really see the fuel cell efficiency, so efficiency fuel cell, if you say 60% is the thermal efficiency, but if you see the overall efficiency from the sustainability point of view, suppose if you consider 100 watts, that is power produced by the wind turbine. So efficiency of the electrolysis is only 75% right now. That is the state of the art. 25% is lost in the electrolysis. And the efficiency of compression, chilling and transportation is 90%, 10% is lost. Hydrogen conversion to electrical, that is in vehicles, that is 60%, that is 40% is lost, that is efficiency. So electricity to vehicle movement is 95%, 5% is lost. So finally, 38 watts only is useful for 100 watts that is produced. So what we are producing 100 watts and we are spending 100 watts of energy, but still you are using only 38 watts. Suppose if you take battery cars, similar analysis if you do, loss in grid from internal turbine to the grid is 5% only. Loss due to charging and discharging is only 10%. Loss from electricity to vehicle movement is only 5%. So if you take 100 watts of power, 80 watts is useful. So there it is only 38 watts is useful. Here it is 80 watts is useful. That is the beauty of this electrical, that battery-driven vehicles. So which is better for sustainability? Sustainability point of view, definitely battery vehicles are better. That is why you can see 5 million, more than 5 million battery vehicles are there on the road, whereas only 72,000 fuel cell vehicles are there. If you take the statistics up to 2022, where is 72,000, where is 5 million? So long way to go for fuel cell vehicles to come to become popular like electric vehicles. That is why the lithium-ion batteries right now, there is no choice. Only we have to use lithium-ion batteries. And that is why a lot of improvements are being done to improve the efficacy or other aspects of the lithium-ion battery. So people are working to increase the energy density, to decrease the weight, to improve safety, and to decrease the charging time. These are the 4 areas people are working, and a lot of developments are being taken place. Some of the areas they are started working is replace the liquid electrolyte. Liquid electrolyte, if it is replaced with a solid state, then the energy density will be high, and we can slash down the charging time. That is the main advantage. This is one area where a lot of work is going on. Lithium sulfur batteries. These are the this is the other area where people are working. So these are some of the areas where we are trying to improve the efficiency and the safety aspects of the lithium-ion battery. And at the same time, battery management system is very important, and the smart battery management systems are coming up, integrating with the AI. So that is to protect against protection against deep discharge, protection against overcharge, protection against overheating while charging, protection against overheating while discharging. And simultaneously, there is an effort to increase the ESD protection of the battery. So these are the areas in which the lot of work is going on in lithium-ion batteries. So if you see the sustainability, right now the battery-driven vehicles seems to be the best solution. And the manufacturing, if you consider the recycled materials and the new, where we can reduce the electricity consumption, that we should be they are taking up in the manufacture also to bring down bring the sustainability into picture. So this is what I want to talk about. What is the status of these electrical vehicles with zero emission and manufacturing, carbon neutral manufacturing. So I wish all the best for this automobile engineering department for conducting this FDP, and all the participants. I am sure you will end up with sweet memories and good takeaways at the end of this 5 days period. Thank you very much for patient listening. Thank you.
Thank you, sir. Now I invite Dr. S. Aslam Ansari, sir, adjunct faculty, to address the gathering.
Respected Dr. Channa Kesavara Garu, Director Administration, Dean Advancement, Dr. Subhanand Rao Garu, Director and Dean Research and Development, Dr. Srinivas Rao Garu, Head Automobile Engineering Department, Dr. Vora Garu, today's eminent speaker, and my dear participants, good afternoon. Friends, the development of any country is directly related to the mobility. Recently, our Honorable Prime Minister, Sir, Sri Modi ji said, the world is now in the middle of a new mobility revolution. So a lot of activities are going on as far as revolution, as far as mobility is concerned. The government of India has started one portal by name e-Amrit, Advanced Mobility Revolution for Indian Transportation. And similarly, one more EV Jagruti. A lot of activities are going on to develop, to enhance the utilization of the EV activities, EV vehicles. And for that revolution, probably this sort of FDPs will help to enhance the utilization of the EV vehicles. And we'll also be discussing about different types of mobility, EV vehicles, particularly battery electric vehicles we'll be discussing, hybrid electric vehicles we'll be discussing, fuel cell electric vehicles we'll be discussing in total the mobility with reference to the efficiency, economy, eco-friendliness, safe, more than that, intelligent vehicle within the framework of the CMVR rules. And we'll also be discussing about the CMVR vehicles, CMVR rules, regulations, homologation, amendments of the acts, everything. And the buzzword is autonomous vehicles. Speakers will also explain you about the autonomous vehicles. My dear friends, the 5 days FDP program will certainly be helpful for you to enhance your knowledge on automobile engineering and autonomous vehicles and so on. With this, I request all the participants to be available for all the 5 days, and all the best for all the participants. Thank you.
Thank you, sir. It is my immense pleasure and privilege to introduce today's chief guest and keynote speaker, Dr. K.C. Vara. Dr. K.C. Vara has completed his BTech Mechanical Engineering from BVM College and Masters in Automotive Engineering from VJTI, Mumbai, PhD from IIT Bombay. He has vast industrial and academic experience of 38 years. Dr. Vara has superannuated from ARRI in 2021 as Senior Deputy Director and Head of ARRI Academy. Besides Professor of Emeritus at College of Engineering Pune, Technological University Pune, he took an additional responsibility of College of Engineering Pune, TPI, Bhava Institute as CEO for an year. He is a professor of practice and an AICTE, IANE distinguished visiting faculty and consultant for many organizations in strategy and diverse operations. He is a strong supporter of industry academia interaction. He has gained a cross-cultural exposure by working with industries and universities from India, Germany, UK, USA, Nepal, and Sri Lanka. And he is chair ASDC expert group for electric vehicles as he is a registered trainer trained under ASDC banner. Dr. Vara is an advisor in various activities of SAE India, under which he is conducted a series of student activities like AWIM and Baha SAE India. He is a recipient of Best Learning Center Award for Array Academy and Knowledge Center from the Indian Society for Training and Development, ISTD, and Guru Award from SAE India Foundation for his contributions to the students of India. He also received Quality Excellence Award for Teaching and Learning Practices and Lifetime Achievement Award by the Open International University, Sri Lanka, and Imperial Society of Innovative Engineers, ISIE. Recently, he has been conferred by Indian Quality Assurance Council, IQAC, for Best Teaching Training Quality Excellence Award. He has 115 technical papers, 4 books, and 3 patents to his credit. Now I would like to welcome our today's chief guest and keynote speaker, Dr. K.C. to give a keynote address on advancements in automotive engineering. We are so glad you could be here today to share your views on present context, sir. Over to Dr. K.C. Vara, sir.
Good afternoon, everyone. And it's a privilege to be a keynote speaker in this 2-week faculty development program, international faculty development program. And we have even speaker from abroad, Ford Motor Company, who will be speaking on one of the days. So it gives me a lot of joy and satisfaction to be a part of this faculty development program. I would just share my presentation and then continue talking. Okay. Share screen. Just 1 minute. Okay. Green. Large. Just give me 1 minute.
No problem, sir.
पहले ये बंद कर दे. हाँ. Yeah. अभी try करो.
One mute time.
पहले Safari
Numeric
settings website. So Safari. Setting. हाँ उधर गए तो भी चलेगा. Setting.
అవునా ఇప్పుడు వెనకాల చీఫ్ గెస్ట్
ये निकल देना है. We'll check it. What is that?
Safari settings for this website to update permission, then refresh the page.
फिर refresh करना है. वापस जाओ Safari.
सर लास्ट टाइम क्रोम से जा रहा है सर,
Uh,
क्रोम से एक बचा है सर।
yeah. Okay, I will try through Chrome. We tried, it's not getting I'm not able to share. So I'll just come up and try to join through Chrome. Please bear with me. Are you able to see the presentation now? Am I audible?
Yes, sir, you are audible. We are seeing meeting, not presentation.
Presentation is seen now?
No, sir. No, sir. We are still seeing that Chrome browser only. Your meet.
Okay, now? Are you able to see the presentation first slide?
No, sir.
Okay, let me try.
Browser. We can see only browser.
Okay. Enter screen. हाँ, अभी आएगा. Sure. Yes. Now are you able to see?
Yeah. Now I can see, sir.
Okay. So fine, all done, and we will start the presentation. So sorry for the
Yes, sir.
disturbance, and we are all ready. I have been given time till 5 p.m. to complete this presentation. So I have around 90 slides, and I will try to finish it by 5 p.m. So today I'm going to talk about advancements in automotive engineering, the main topic of the faculty development program. So I would try to cover various aspects of advancements in automotive engineering. And you must have heard that there are flying cars or a drone taxi. Maybe if in Bangalore from Whitefield to the airport, we may use a flying car, or there are flying cars in Dubai, or we are talking about hyperloops like Dubai to Abu Dhabi, Mumbai to Pune, Chennai to Bangalore, Baroda to Ahmedabad. There would be in future hyperloop trains which can just travel in 10 to 15 minutes. We already have in Dubai autonomous car where pizza is delivered. And we are also talking about future cities where there would be seamless mobility. There would be only electric vehicles. There won't be fuel used vehicle in smart cities. So with this scenario, we will see that the world is continuously changing. So probably in this century, we will have someone born on a different planet. So we will be able to go to another planet and have an habitat there. And all the products which our grandchildren will be using will be all after 2017. All those which is invented before 2017 may become redundant. That is the way how the technology is moving fast. The average lifespan of human will be in 3 digits, so more than 100 years. And that's all possible because of medical technology. And by 2040, many countries will have separate lane for cars that are human driven. Today, all the cars are human driven, but in future, most of the cars by 2040 will be autonomous, but still there would be one lane where the old cars which are human driven would be allowed. So that is what is going to change. And this is all possible because of 3 reasons: growing economy, increasing consumerism, and digital exposure. Because of these 3 things, there has been a very big change in Asian countries. And we can say that mobility has gone through a transformation. Mobility is changing the way we look at it. We are now talking about shared mobility. We are talking about last mile connectivity. And then we are getting different types of services, whether it is booking of a bus through Redbus or use of Ola, Uber, Zoom. So digitization has resulted in the emergence of a new shared mobility. And today's generation want everything on rent, and they may not buy a house or they may not buy a car. So there are certain challenges in mobility. High expenditure due to improved standard of living. So if a neighbor buys a car, we also need to buy a car. That is what is the high expenditure. There is very high congestion because the vehicle population is increasing tremendously in cities like Pune. The number of vehicles have outnumbered the number of human beings. That means the vehicle population is higher than the human population. Because of this, pollution levels have gone high, especially with IC engine vehicles, and carbon dioxide and COHC NOx have tremendously increased. The norms have become stricter from BS1 to BS6, but the number of vehicles have increased exponentially. Around 300 million vehicles are running on Indian road, and that is why whatever we do, whatever strict norms will do, as the number of vehicles are more, it will be very difficult to reduce the overall pollution. Also, we have been buying oil and refining it and converting it to petrol and diesel and other fuels. And till what date can we continue buying oil? And the fluctuation of oil doesn't allow us to be dependent on that. So we need to work on other fuels. And there are a lot of road accidents and death. So Nitin Gadkari ji once again said that his target is that he would try to reduce the accidents by 50% by 2030. So we are trying to find solution to this challenge. It's not that we are not trying. We are trying our hard, and we are moving towards new technology. We talked about last mile mobility. So there are metros, and there are railway stations, there are buses, and there are a lot of new modes of transport, BRT. But then if one has to move from home to office and office to home, last mile connectivity is a major problem, where we will be able to use shared accommodation like bicycle, two-wheeler, or Ola, Uber type of vehicles. This will also reduce congestion in a strong extent. So now the technology is moving towards ACES, autonomous, connected, electric, and shared mobility. Autonomous will give us safety and less fatigue to the driver. Connected will make us more accessible and convenient. Electric will lead to zero emission, at least in the cities where this vehicle are used. Somewhere else where electricity is produced, there would be pollution, but we need to move towards green energy. That means we need to use solar and wind energy and hydel energy to charge electric vehicle. And shared mobility, most of the time 95% of the vehicle are in parking unused. But if we start sharing our vehicle or we use shared mobility, then there is a better utilization and reduction in congestion. So ACES is an acronym which is used in US and Europe. But if you look at the Asian context or the Indian context, we can slightly tweak it. The acronym still remains ACES, but instead of autonomous, we can talk about afforded and assisted mobility. Instead of connected, we can talk about connected and shared mobility. Instead of electric, we can talk about eco-friendly mobility. So whether it is hydrogen or electric vehicle. And shared mobility, instead of shared mobility, we can talk about safe mobility. So a slight tweak will help us to have ACES in the Indian or the Asian context. We talk about Vikasit Bharat and how do we launch into the future, how automotive industry will move towards Vikasit Bharat. There will be favorable macroeconomic and market condition. Customer would be empowered. There would be retail innovation in sales and marketing. The future of the mobility will become more stronger as more and more people start living in the cities. And it is said by 2030, more than 50% of the human population would be in city, and hence there is a need to develop smart cities. There is uncertain future of electric vehicle and whether IC engine would come back through fuel cells and hydrogen as a fuel. And then also we need to discuss on the evolution of after treatment market. So there is a growing demand, there are opportunities, there are rising investment, and there is a policy support through the government. All these four aspects is helping Indian automotive industry to boom. If we look at the automotive mission plan, up till now we had two automotive mission plan, 10-year plan. One is from 2006 to 2016. In 2006, we were 11th largest passenger vehicle manufacturer in the world. And our target was to be 7th largest. In 2016, we were not 7th, but we were 6th largest passenger vehicle manufacturer. We surpassed our target. And then in between 2016 to 2026, our target is to become the 3rd largest passenger vehicle manufacturer in the world after USA and China, and we are almost there. GDP in the previous 10-year was contribution of 10%. Now the GDP contribution is expected to be 12%. We have not reached that target, but I am sure that by 2026, we will be able to reach those targets. And there will be an additional employment generation of 65 million people in 10 years. That is what is the target of the Vikasit Bharat's Automotive Mission Plan 2026. So we also talk about sustainability in this faculty development program. The last word is very important, sustainability. So maintaining the capability to provide non-declining accessibility in time. Sustainable mobility means something which helps PPP, profit, planet and people. That means profit means there must be an economic growth and you, me and everyone in the country prospers. Planet means we take care of reduction in noise and vibration. And social progress means the people get benefited from this. So people from the masses get benefited and have a better standard of living. So these 3 P are also called the bottom of the pyramid to sustainability, and sustainability is here to stay with us for a longer time. So in the present sustainability mobility challenge, we will have to work towards all this area which we discuss, and we need to find solution. And sustainable development goals are the 17 goals are some of the areas where we can work on, provided we are able to take care of some of the sustainable goals. For example, climate action. So we must be careful of carbon dioxide and how they are being emitted, and how can we reduce the carbon dioxide content. So if you look at the sustainable mobility challenge, climate action, sustainability mobility number 13 tells us that the overall temperature worldwide will increase. It is happening in London, it's happening in Europe, it's happening in India, it's happening in Hyderabad. The overall temperatures are higher and the summer is worse. So it is said that around 20 to 30% contribution towards climate change comes from automobile, and that too with the around 300 million vehicles running on road with old emission norms. So global warming is a serious topic of debate and discussion across the globe, and need to work towards a green future through climate action has become clear. So vehicular emissions are a major contributor to global warming, and according to a study, the greenhouse gas emission have now increased more than twofold compared to 1970s leads. The transportation sector contributes to the quarter of the total global emission, out of which 3/4 of the emissions are contributed by the road transportation sector. So the current scenario talks about we have been using electric vehicle, but in future we will be using electric and hybrid vehicle. There are challenges which degrade the well-to-wheel emission reduction potential of these technologies, excessive use of gas-powered mode in hybrid vehicles, and so on. So we will have to reduce the carbon dioxide emissions, which will reduce the overall the temperatures of the climate. So a very good lesson would be the story of Inconvenient Truth, a video which talks about the frog psychology, that when a frog is placed in the boiling beaker, it enjoys the warmth till he realizes that the water is becoming very hot and he needs to jump out. But by that time, he has lost the energy to jump out. So we are all those frogs who are enjoying the warmthness. And one day when we realize, it will be too late for us to jump out. And hence, it is time that we need to take care of our planet Earth and take care of reduction in global norms. Okay. So let us look at the prevailing condition where economical conditions are not so conducive. We have been buying crude petroleum for a long time and it's not reducing. Society is another area where, because of increase in traffic, more and more people are shifting to cities, and there will be more traffic in the cities. And the production of two-wheeler, three-wheeler and four-wheeler in India is more encouraging. So we can call this as Kyoto Protocol, and using this Kyoto Protocol, it is our duty to reduce overall emission and the carbon dioxide emission. We produce around 25 million vehicles every year, out of which around 4 millions are two-wheelers and around 4 million are passenger vehicle manufactured. So EV has been here in India since last 5 years, and it is the changing phase of the mobility. And we are now talking about zero emission vehicle, where the rise of electric vehicle would become obvious in the 21st century. So Government of India has come out with series of initiatives to support electric vehicle through FAME, and the first electric mobility mission plan was released in 2011, and then in 2013 the National Electric Mobility Mission Plan is published. And then we have FAME 1, FAME 2, Charging Infrastructure 1, Charging Infrastructure 2, and there has been a lot of refinement in the standards. However, even if we are able to reduce this to electric vehicle up to 64% and 37% of carbon emission by 2030. So now FAME 2 is over, and now we are contemplating FAME 3, where hybrid vehicles would come into picture. Up till now, India being very conservative in terms of finance, we have been using electric vehicle, that is a battery and a motor. It's a much cheaper way. But in future, e-kit and engine would go hand in hand. It will become a hybrid vehicle. We need to develop an e-mobility ecosystem, and for developing that, we need to support startups, new entrants, OEM suppliers, signals, dealers, availability of finance, charging infrastructure, favorable regulation, customer awareness. These are some of the ecosystem development done through this organization. So when we talk about future trends in e-mobility, a lot of new things are going to come up which will suit Gen Y, and whether it is new player or old player or new markets. So there is a lot of future trends in e-mobility, and with new generation of vehicles and new generation of human being, we need to wait and watch on what types of car would be running on roads. But we are very sure about some of the emerging market. For example, electric mobility, use of powertrain and lithium-ion battery is one such area. Lightweight material and lightweight, stronger and lighter material is another area. Rapid advances in connected vehicle, in which we are talking about vehicle to infrastructure and vehicle to vehicle communication technology. Shift in mobility preferences, where we are talking about younger generations who would use their smartphone app for transport and already plan travel so that they can multitask. Emergence of autonomous vehicles are also not far away. Our government is still not approved usage of autonomous vehicle, but it is going to come in a very long way. So autonomous drive technology is here to stay. So let's look at the car of the future. In the next 20 years, the automotive industry will go a profound transformation. In terms of car it builds, in terms of the company that build them, in terms of the consumer who buy them, and look significantly different. So technology will be leading the change, but it will be shaped by key themes. So here are some of the key themes: sustainable, convenient, safer, affordable, and smarter. So this is what is expected from a vehicle. And vehicle also has to be sustainable, because 20% of the vehicle moves with around say 15% sustainable car of the future. So the transport sector plays a very important role here, and sustainability plays another important role. Okay. Then we talk about convenient car of the future, that as I told you, more and more people will shift towards urban population, that is 50%. We have time to ensure how cars can sit unused for such a long time, and what can be done to address the energy. So the average time spent in traffic jams by everyone in Japanese is around 5.5 million, that is, and around 7 million people have visited. Okay, fine. So let's go ahead. Also, the car is to be affordable. So today we are selling around 7.4 million vehicles worldwide, whereas China is selling around 35 million vehicles, and overall remaining global is 120 million. Okay. So we also need smarter cars. Smart mobility is a novel and revolutionary approach on how we move around, and what is the expectation and how are they filled. So under smart mobility trend, connected and autonomous, the connected and autonomous vehicle will take care of basic safety, will take care of So basic safety, convenience and comfort of the driver, preemptive safety, seamless connectivity, and internet of car. These are the 4 areas which one has to work to make it more smarter. Okay. So up till now, the trend has been eco. So up till now, we were talking about economic model, comfort model, and sports car. But now we are talking about more related to sex, to relax and socialize. We must be able to work and concentrate inside the car. So probably the car seat would be in the circular form so that you can face each other and work together. Or it must be able to give good mode of entertainment to ensure that the smart mobility continues. Okay, so we are now talking about connected and autonomous car, and here 4 areas: vehicle to infrastructure, vehicle to cloud, vehicle to pedestrian, and vehicle to everything. V2I, V2C, V2P, and V2X are some important aspects. Am I audible, sir? Sir, am I audible?
Yes, sir.
Hello? Yeah,
Yes,
fine.
sir.
So
You
we are
audible,
halfway through. Thank you. We are halfway through, and it is around 4:10, and I target to finish by 5. So we need to work in this area of connected and autonomous vehicle. Organizations like TIHAN, IIT Hyderabad, ARAI, ATS, and many companies like JLR, Continental, Valeo, Daimler Truck have been working in this area. So basically, V2V communication and autonomous vehicle approach will help us to move in that direction. So basically, we will have to understand the connectivity and the connected platform in terms of hardware, in terms of software, and we will have to update ourselves in this area. In terms of small mobility trend, connected and automated connected vehicle, the journey would start from home, go to the charging station, then pass through a tunnel, pass through an e-toll, keep on paying toll, and then there is a hotline. Okay. So what are automakers doing? So automakers are working in all this area, whether it is monetization, whether it is privacy, whether it is user experience, global design, all these areas one has to work to become a successful automakers. And similarly, in terms of connected and autonomous vehicle, what platform help achieve? What do platform help achieve? So whether we require a platform or whether we don't require a platform. So if we have a platform, then we are taking care of safety and security and sustainability consciousness. And so this platform will help us to achieve benefits to the customer and the benefits to OEM also. So here we are now in the era of connected and autonomous vehicle, and artificial intelligence would be one aspect which we will learn in this. As far as the technology is concerned, we are moving from traditional technology to current trend to future trend, and there is a shift in intelligence and complexity. So when we talk about smart mobility or autonomous car, you would hear subjects like multi-purpose camera, stereo video camera, and so on. So here you can see that there are pedestrian protection devices, turning and crossing, traveling. These are the areas which are vulnerable to the drivers. So looking at the trend of simple wordings, autonomous and connected vehicle would start with ADAS, Advanced Driver Assistance System, where there would be an interface to the end user, there would be a navigation system, an environmental perception system, a vehicle context system, active safety system, vehicle control system, and various actuators and sensors. Okay, so you can see how smart mobility would help. One by one, every year, one or the other sharpness is added. It started with evasive steering support and remote park assist, and then we shifted to in 2018 towards highway assist, integrated cruise assistance, and so on. So when we talk about autonomous vehicle, there are 5 levels, and as you move from left to right, the autonomy levels increases, and the requirement of human as a driver reduces drastically in level 5. So what is important is that you need to work on the efficient strategy where you can take level 3, and level 3 is the most suitable in India today. We have cars with level 1 and level 2, but level 3 is something which is difficult to achieve, but we are all moving towards it. So looking at the autonomous vehicle, we need to work on vehicle-to-vehicle communication and conditional driving automation and human behavior. So when we talk about autonomous vehicle, we will require 3 areas: vehicle control, that means use of actuators and throttles for steering, for braking, and a throttle for accelerator is already there. And then we talked about various sensors required, whether it is vehicle sensor like radar, camera, lidar, or a connectivity sensor, or a fusion, where multi-sensor data, power computing, cognitive ideas fuse. Okay, so we need to work on the logistic infrastructure and how can we give more work to certain people at strategic level is very important. Okay. So the car will have cameras, radars, and lidars, and the car will be intelligent enough to understand what is in the rear, what is in the side, and what is in the front, and what precautions are required to be taken. One second. Yeah. So when we are talking about radar, lidar, and cameras, then we must know how to fix them, where to fix them, and how to use them. So in future, the car will look something like this, where we will have originally the electric vehicle and then converted into autonomous mode with lidar, with camera, with radar, ultrasonic sensor, current, and radar sensor. So various technical features of autonomous car would be adaptive cruise control, autonomous emergency braking, blind spot detection, electronic stability control, lane keeping assist, reverse park assist, rear cross traffic assist, and so on, right? So this is how the car will look like from rear. Okay, fine. And then we will have to work on the control structure in terms of navigation, maneuvering, and trajectory. And then we will have to work on various sensors and its data fusion and various techniques used for fusion technology. So we will have to move from AC, autonomous car, level 2, which talks about ACC and lane keep assist support, and then we move towards higher level like integrated cruise assist, highway pilot, and autopilot, and so on. So we are now left with around 30 slides. and we have still time, 45 minutes. So autonomous technology is here to stay. Government of India is still not approved autonomous technology for our cars, but I am very sure that autonomous vehicles would be moving in some confined area, like from Bombay, there are 2 airports, one domestic, one international. So from domestic to international and back, they have a separate road, and maybe on that autonomous vehicle may run, and so on. So we have also started a competition called E-Baha, Autonomous Baha, where any engineering college students can participate in E-Baha, but only participants in E-Baha. So basically, students will make a Baha buggy, which will run of its own and would stop of its own, and it will work on various commands given by him. Okay. So the primary objective of the Baha is learning and make them industry ready. And for that, we use an all-terrain vehicle. We have a Baha rule book, which is completed every month, and also out of classroom education. Okay, so Baha would bring, so we started with M-Baha and E-Baha, but I am very sure with this year, last year, when we introduced H-Baha and A-Baha, hydrogen Baha and autonomous Baha, there is more participation. So I will quickly now talk about autonomous Baha and hydrogen Baha, the new 2 technology which many of my predecessors talked about. So in a Baha vehicle, basically there is a roll cage which is ergonomically need to be designed, and the driver, single driver sits inside and he checks of his ergonomics. Okay. Then we need to design a system where we have a vehicle with less than 164 kg and a particular lithium-ion battery and motor and a controller. So here are the salient features, like the total power should not be more than 9 kilowatt and the weight must be limited and so on. Okay. So we are talking about systems which are level 3 automation, and that will go a long way. So they are using sensors. Okay. And so various softwares would be required for level 3 automation. Software, hardware, all this would be required. So here you can see some of the suggested tests. For example, you can see the pedestrian safety. Let me show you a video. So here you can see a car is coming and the pedestrian is passing by, and the car must be able to see the vision that the pedestrian is crossing, and it will stop. And after the pedestrian is crossed, the car will restart and move ahead, right? Similarly, you would see here. Yeah, sorry. You would see that at various speeds, the vehicle will move, and it has to still find out what are the obstructions on the way. Or you would find a maneuverability event come, and endurance event where the cars would continuously move on a particular desired left. Okay, fine. So we also need to look into the all-terrain performance where the vehicle will be able to run on rough road. So it has to overcome various traffic signs, traffic signals, pedestrians, moving animal, and 2, 3, and 4 wheelers. So the present system may have a LiDAR and or radar and camera and so on. And then using this 3D model, we need to integrate it with the 2D model. And here you can see how vehicle can be modeled using IPG car maker. So modeling of vehicle would require generic longitudinal control generic lateral control and acceleration control, and we will have to use various sensors and actuators to make this happen. The track, so we need to model a track, we need to model a vehicle, we need to model a driver, and then the model driver will run on the model track using a particular algorithm and the maneuver. So when you model a track, you also can model a car or deer or a man crossing the road. So I would just like to show you a couple of animations. We are almost done. So here you can see the car is moving in a straight line, and there far away you can see a pedestrian ready to cross the road. And now the pedestrian is about to cross the road. Here it enters the road, and because of which the vehicle is forced to stop. And now the pedestrian is left and the vehicle can move ahead till he or she comes across the next pedestrian. So the car is moving in the straight line and you can see a red signal. The car stops at the red signal. And then when the green signal is there, the car will move forward and take its own course, say left course, to reach the hotel. Yes. The car has taken a turn and moved forward. Okay, so this is how you can use IPG Car Maker to model a track, the driver, and the vehicle itself. So let's see one more simulation. The vehicle is moving in a straight line and then taking a turn. And then it is controlling the headlights, and it is also controlling what it can see through the camera. Here it is. Here it is stopping at the signal, waiting for the signal to become green. And when the signal is green, it will move to its left. Okay. So that's about autonomous car and how they behave. Okay. So there is a need for diagnostics and prognostics, and we need to collect vehicle data in a black box, which can be retrieved later on, and the notification should be real time. Okay. So India is committed itself. So this is about autonomous, and now I have around last 10 slides where we talk about hydrogen. So autonomous electric, shared and autonomous vehicle and connected vehicles are here to stay with us. As the roads become better, and maybe some roads would be used only for autonomous to start with. India has a commitment. Our Prime Minister has given a commitment that India has set its sight on becoming energy independent by 2047. Today we are in 2024, and by 2047 we are going to become energy independent, and also we will achieve net zero by 2070. We recognize the critical role of German hydrogen. So India, with its vast renewable energy resources, also has the opportunity to produce green hydrogen for the world. So green hydrogen using electricity, normal electricity, can lead to green hydrogen. And this is the booklet Sir talked about, National Green Hydrogen Mission Plan, which was released in January 2023. And this National Green Hydrogen Mission Plan talks about the plan where MNRE released the National Green Hydrogen Mission Plan, and the National Green Hydrogen Mission Plan to provide a comprehensive action plan for establishing a green hydrogen ecosystem and catalyst a systematic response to the opportunity and challenges of this sunrise sector. So Ministry of New and Renewable Energies, Energy MNES is responsible for this. An objective of the mission is to make MNRE will take care of this mission, and the objective of the mission is to make India a global hub for production, usage, and export of green hydrogen and its derivative, most of the time the green hydrogen. Okay. So there are various mission components. There is a need to demand create, there is a need to incentivize the supply, and then there are key enablers. So under National Green Hydrogen Mission component, we need to find out how many exports are pending, and the expected outcome will look somewhat like this: 5 metric ton per annum. Then renewable energy, 125 gigawatts, and against this, 50 million metric ton per annum, and create full-time jobs, more than 6 lakhs full-time jobs is what is the idea under Green Hydrogen Mobility Mission Plan. So the landscape will look something, somebody will work on generation of electricity and use of electrolysis for production of hydrogen, or storage, or the application based on which you would get experts to work on it. Okay. So India hydrogen landscape looks something like this, where we are talking about energy generation, hydrogen production, and so on. So finally, it is the hydrogen which is used by the end use customer. Okay, fine. So I talked about autonomous Vaha. Quickly, 3 slides on hydrogen Vaha. We started in 2024 with 100% CNG. In 2025, we will be using HCNG, that is hydrogen in CNG. So up to say 18% hydrogen would be allowed to be used in CNG vehicle, and still it is safe, but it is not 100% safe because hydrogen is something which you cannot smell and you cannot see. So that is the registration of preliminary round of Vaha. Then for use of CNG or hydrogen, we require a fuel injected engine. So we worked on an old engine and converted that into a fuel injected. And we use a Greaves engine, Greaves 3-wheeler engine, which has 350, which has around 35 horsepower. And okay. So it says that if you want to move towards sustainability in automotive engineering, we started with conventional fuel, which were coming through the crude petroleum, and then we started working on the improvement. Much improvement was not done, but now we can see the after effect of all this technology. So we can use alternate fuels, we can use hybrid and EV technology, but in future we would be using hydrogen technology, and that is what seems to be the future. So with this, I complete my presentation. Thank you very much, and I'll be very happy if there are some questions.
Participants can raise hand so that I will give you mic to ask questions.
कैमरा दिखना चाहिए. Okay. Yeah, there is a question from Sridhar Sahu. Sir, can we unmute Sridhar Sahu?
Hello.
Yes.
Yeah, good afternoon, sir. This is
afternoon.
Dr. Sridhar Sahu from IIT Kharagpur. So, I just have one question. Being a graduate engineer, a student should focus in which aspects of this automotive domain in order to achieve that Viksit Bharat goals. I just want you to talk about this, particularly for a student's perspective.
Particularly for the student?
Perspective, in which areas he should work.
Okay, of automotive engineering.
Right.
So see, automotive engineering has various aspects, and one, so as I told you, ACE has autonomous and connected vehicle, shared mobility, electric vehicle, safety of vehicle. So first, the student must know what are the various systems of an automobile and what are the different parts of an automotive system. And then he must understand the functions of each this system, the failure mode of this system. He must learn to do design FMEA and how validation would be done. So this is the first area where he will clear his fundamental and understand. Then from design point of view, he has to learn the new product development. So all multinational companies use the method of new product development, where they understand that they have to design, they have to get it reviewed. So there are design reviews, there are 5 design reviews at various stages. They need to make prototype, they need to do validation, they need to come back with more mass production, and then showcase, right? So that is another area, new product development. Third area is technology. So they must, automotive is multidisciplinary. So they have to learn electrical, electronic, computer, mechanical, everything together, and in a short span of time, that knowledge could be checked. So overall knowledge of autonomous vehicle, hydrogen vehicle, are something which one has to work towards. So that this will bring in an overall grooming of an individual. Am I correct, sir?
Yeah, I completely agree with you. But one thing I also doubt, like this needs a good amount of collaboration between the automotive companies and the research institutes. So, is there any facility or any collaboration that is in between these institutes
Yes.
with the companies?
Okay, I'll explain you. I am a very strong supporter of industry academia interaction, and there is a big gap. The gap is reducing, but it is not reduced to that extent. So, Government of India, Ministry of Industry has given funding to various organizations like ARAI, ICAT. ARAI is Automotive Research Association of India. ICAT is International Center of Global Technology. Then GRC, Global Automotive Research Center in Chennai. So all these organizations have been given special portal where students, faculty, industry professionals, startup can join those portal. For example, the portal which is used by ARI is called Technovus, ECHNOVUUS.
I know that.
Yeah, similarly, ICAT has one portal called, and even IIT Madras has one portal. So any student, any faculty, any industry, any startup can become a member of this portal individually and ask for help. For example, recently through IIT Madras portal, around 100 students were selected and they were given stipend, their stay and food was also arranged, and they were sent to various organizations for training. So ARI conducted those training for more than 100 people, and everything was free. So yes, there are avenues where we can go and take help. Otherwise, individual college, it depends on relationship of professor and HOD with the industry, a one-to-one discussion may also help to get a lot of support.
Okay, okay. Thank you, sir. Thank you a lot.
Thank you, sir.
Sir, this is Bhaskar from Rajalakshmi Engineering College, Chennai.
Yes, Bhaskar.
I'm heading automobile engineering department actually. How to focus on the syllabus to be framed for a current generation automobile engineers. Most of the courses which are related to mechanical engineering, up to second year, we are using thermodynamics, strength of materials. Almost it is jam-packed.
Yes.
And how we are focused, we have to focus on electrical and this autonomous vehicle.
Electric, autonomous, and hydrogen economy we need to work on. So I think our education system is going to change. We are moving towards new education policy, and skill will have more importance than the knowledge, or they may have equal importance. So it's not just knowledge which is important, the skill also needs to be added. And that's what the ministry said. So it's AICTE and ASDC, Automotive Skill Development Council, and AICTE together needs to join hands and ensure that skill and knowledge is imparted to the students. There has to be some part where students have to do self-learning. So possibly a time would come where less importance will be given to fundamentals like how to design a suspension, steering, and brakes. So people who are participating in events like Baha Supra would learn of their own how to design them, and they will then have to work on interdisciplinary area where knowledge of electrical, electronics, computers, and automotive engineering will be required, and they will have to learn this technology of hydrogen, HCNG, alternate fuel like LPG, methanol, ethanol, biodiesel, all this area. That is one area which they must work on. Second area is the EV and autonomous vehicle. That is another area which one must work on. So one can take specialization. So if I take hydrogen, then I will not take electric vehicle, or if I take electric vehicle, I may not take hydrogen. But I would suggest a student must take both, because finally it would be survival of the fittest, or both the technology may coexist 50-50%. Because India is a land of diversity, we do that. So these are some of the areas which student must possibly learn, and some area they must learn through exposure. They may not sit in the classroom, and maybe some prescribed books and references may be given, and they must be able to do self-learning. So I think at higher level, spoon feeding has to reduce and self-learning must happen.
Thank you, sir. But still, the automobile engineers will be coming under the mechanical engineering scope. If they want to go for gate examination, again, they have to read all the basic things.
Yes. So this is a confusion. I got your point, sir. If see, anyone can become an automotive engineer or an electric vehicle expert. If he is a mechanical or an automobile engineer, he needs to do a bridge course on electronics and electrical engineering. And if he is an electrical or electronic engineer, then he needs to do a bridge course on mechanical or automobile engineering, so that they all come at par with the same knowledge. So this would require till we change our education system. Yes, I have seen in most of the engineering college, it is a mechanical department which takes the lead in EV. But then when it comes to power electronics, when it comes to electric machines, they are helpless and they need to take help of the electrical department. So if this is understood, and then if we get teachers who can teach multidisciplinary area, then it would be great.
Thank you, sir. Thank you.
Hello, sir. Good afternoon.
Good afternoon.
I am Divya from Bahrain Polytechnic. It was very nice to hear whatever you have spoken in the recent trends of automobile. I know that there are multiple initiatives taken by the government to reduce the carbon footprint in usage of automobile industry. But my question to the recent drift is that we are using electrical vehicles. There is a lot of investment in the electrical vehicles, but still we are getting the electricity from the same fossil fuels. So is there anything in the future how we can get the demand balance by using non-fossil fuels for generating electricity and then implementing that electricity to run the electric vehicles.
Yeah, so I must tell you that Government of India is working very strongly on generation of electricity using green energy. So a lot of solar power stations and windmills have been erected to harness green energy, and eventually the thermal power stations will reduce and will stop, and more of solar, wind, hydel, and nuclear energy would be employed to cater to the need of electricity required for charging electric vehicle. This is one area. Second area is we will be moving slowly from electric vehicle to hybrid vehicle. India being a cost-conscious country, we started with electric vehicle, and FAME 1 and FAME 2 gave more support to the electric vehicle and not an hybrid vehicle. But eventually we will be giving support. Maybe in FAME 3 there is a support to hybrid vehicle where the vehicle will charge of its own. There will be an engine and motor combination where the vehicle will be charged of its own. It does not require extra electricity. And if this happens, then the requirement of electricity will drastically go down. But looking at so much of electricity required, we need to generate electricity, because as a human being, we are using more electricity, more ACs and cooler at home. So that consumption is going to increase, more population, so further consumption is going to increase, and more vehicle population means again further electricity consumption will increase. We have to be very careful, and hence we need to generate more green energy, electricity. I'll just give you one example of Switzerland. Switzerland is a country which does not produce any vehicle, neither they produce electricity. So before few years, they took a decision that we will convert everything into electric vehicle, and they almost stopped sale of IC engine vehicle, and electric vehicle were promoted. And electricity were coming from neighbors, that is Germany and France on either side. And then Germany and France also started working on electric vehicle, and they also promoted electric vehicle. And there also the usage of IC engine vehicle drastically went down. And then they were short of their own electricity. So one fine day they told Switzerland that we will not be able to give you electricity because our own country has so much of electric vehicles now. And then it was a very difficult situation at Switzerland that they had all electric vehicle and there was no electricity coming from neighbors to give it to charging. And then they had to stop usage of electric vehicle and again go back to IC engine vehicle. So this is very, very important that a country which is moving towards electric vehicle and hybrid vehicle, they have to ensure there is enough electricity generated through unconventional way or through a green energy way. Then only we will be able to ensure the diversity of various vehicles, and hence it is very much essential that all this technology will coexist. So we will have CNG, LPG, ethanol, methanol, biodiesel in one side, and we will have petrol and diesel on the other side. We will have hydrogen and fuel cell on third side, and electric vehicle on the fourth side. All of them will coexist, and each of them will take its own pie, and only then we will be able to sustain. Otherwise, it is very difficult if we stick to one technology. I hope that answers your question.
Yes, sir. Very much. Thank you.
Sir, this is Dr. Ansari.
Yes.
Sir, in India, the production of vehicles is in multifold, particularly after Corona.
Yeah.
The car buyers are increasing day by day.
Yes.
And the aim of the government of India is to reduce the accidents by 50% by 2030. That is one side.
Can you repeat the last sentence?
The government of India is planning to reduce the accident by 50%. So, sir, do we have the growth of road network in comparison to the growth of production of vehicles, sir? Are we going to have less
I'll explain you.
more cities?
Yeah, sure. I understood your question. So one thing is that the growth of vehicle is very fast. As I gave you an example that in Pune city, the number of vehicles have outnumbered the number of human beings in Pune city. So that's very alarming. in India, we have around 300 million vehicles running on road, and these vehicles are older than us. So that means the life of a vehicle in India is higher than the life of a human being, and 3 generations use the vehicle. This is one aspect which we must consider. Second is we have not gone into scrapping of vehicle. We are planning, but it is going to affect the economy when we say that each and every vehicle, when they complete 50 years, needs to be scrapped. And then we need a scrapping policy and scrapping station which are coming up. Slowly they are coming up. And we have declared the scrapping policy for transport vehicle. That means auto rickshaw, taxi, and transport buses. There is a scrapping policy. 15 years, it has to be scrapped in the city. Maybe those will get extended to the villages or will be retrofitted. So an IC engine vehicle can be retrofitted with EV. So one big question is, what do we do with 300 million vehicle, number one. Number two, we are producing around 25 million vehicles every year. So India this year would produce around 5 million passenger vehicles and 20 million two-wheelers, around 1 million three-wheelers and 1 million buses and trucks. So this comes to around more than 25 million vehicles. And yes, we are moving in a race where we want to be the 3rd largest vehicle manufacturer in the world after China and US. And that's what is linked to the economy. So we need to work on it. But then it is a very big thing that how are we going to control all this vehicle on the road? And the number of roads are limited. Yes, Ministry of Transport is working very hard to accelerate the making of roads and highways. And our road network is becoming better and better. If you now move out, you will see how the roads have improved a lot. But then they have to take care of the safety aspects. For example, when you go on a highway and there are no hotels around, no restaurants around, and the vehicle moves for on a monotonous speed for 300 kilometers or 200 kilometers, accidents are bound to happen. So that is one aspect one has to consider. But in my opinion, if the road networks are not increasing and the number of vehicles are increasing exponentially, and the economy is also booming so that more and more people are able to afford two-wheeler and in future four-wheeler, then scrappage policy has to be very strong, and retrofitting is another area. Only then we will be able to reduce the overall vehicle population, we will be able to reduce the traffic, we will be able to reduce the overall pollution. So scrappage is the only solution I can see. We need to work towards that.
Thank you.
Sir, Ratnaraj, please unmute and talk. Hello?
Yes, please.
Ratnaraj. Okay, I think he's not on call. Bharat Ankur, please unmute and talk. Mr. Bharat Ankur.
Yes, Professor Dogra. Yes, Professor Ambati, Pawani and Ravi Rai, you can unmute and talk one at a time. Professor Dogra, Professor Pawani, Professor Ravi Rai, do you have any questions? Yes. You can unmute and ask the question. So I think there are no more questions now.
Sir,
Yes,
one
sir.
more question. Sir, one
Yeah,
more
please,
question.
please. Yeah, I'll be very happy to answer. Please go ahead.
Yeah. Sir, how about the charging stations establishment in India? Because, for example, if you want to take the fuel, petrol or diesel. For every street corner, we have a station, petrol station. But as far as charging stations are concerned, is it not discomfort to the electric vehicle owners for not having sufficient number of charging stations?
Yes, yes, I do understand.
Is
So
there
whenever,
a plan, is there a plan by the government, sir?
yes, yes,
Or vehicle manufacturers together?
Sure, sure. So there is a policy under FAME 1 and FAME 2 where some amount of money has been kept for charging stations. Around 1,000 crores of rupees has been kept aside for charging stations. And what government, so we will discuss these aspects, like if we have a hybrid vehicle, then the requirement of charging will drastically go down. So we need to shift from electric vehicle to hybrid vehicle, number one. Number two, it is recommended that we do charging at our home. So if we want to travel up to within the range of the vehicle, then every evening we can charge our vehicle for 4 hours at our own parking, right? So that is second aspect. But vehicle which are going to run for a higher kilometer and needs intermittent charging, then we need charging stations. So a proper planning has to be done. Say if you want to go from Bangalore to Chennai or Pune to Mumbai, a proper planning has to be done that what is the charge, and one has to find out where is the charging station and accordingly plan. There is a provision that you can carry your portable charging system also with you and plug in and charge. When the country shifted from leaded petrol to unleaded petrol, with the advent of catalytic converter in the 80s, the same problem came, and the government said, Ministry of Petroleum, that every 200 kilometer there will be a unleaded fuel station. And then later on that it was 250 kilometer, then 200 kilometer, and that changed to 100 kilometer. And then unleaded petrol was available across the country and the problem was solved. Similarly, we still have a problem that for a long distance application, we still are not able to use electric vehicle because there is a fear that we do not have high charging station. So government is working towards that. So the best method is they have talked to all the petroleum industry, which is also a part of Ministry of Petroleum, Bharat Petroleum, Hindustan Petroleum, that they have started working on the charging station. Just for an example, Bharat Petroleum has taken up the entire southern India, that is from Karnataka to Kanyakumari. They are building up charging stations at every 200 kilometers to start with. And slowly they will fill those intermediate gaps also and make it 100 kilometers. So you will get charging stations across the country with time. So patience is the only solution, and proper planning so that you are not held up somewhere in between if your vehicle suddenly discharges. And then there will be fast charging and slow charging. So slow charging is something which you use at your home. It takes 4 to 5 hours for charging the vehicle if you do it every day or alternate day. But when you are on highway, when you are on the road, you require fast charging. So fast charging facilities would come up. But one must be careful. The more fast charging you use, less will be the health of the battery. So we need to do a good combination of slow charging and fast charging. And as far as possible, do slow charging. But if there is no other option, fast charging would be also available for people to charge their vehicle on the road. I hope that answers your question.
Yes, sir. Yes, sir. And sir, when it comes to the two-wheelers, electric two-wheelers, 1 year back or a couple of years back, so there were incidents where the vehicles got burnt.
Yes.
What are the steps, statutory steps of the government to strengthen the safety rules?
Yes. So the standard has changed, especially for two-wheeler. It is called L2 category. I think my colleague at CIRT will talk about this, but I will quickly answer. So there was a time when there was no thermal management, and inside a battery there are modules. Say for example, 6 modules packed together to get a battery pack, and each module will have a set of cells placed in parallel or series to decide what voltage and what ampere hour the battery specification is. Now each and every cell is an individual cell, and the temperature must be uniform, and as far as possible the temperature of each and every cell must be between 10 degrees Celsius to 50 degrees Celsius. If this temperature does not remain uniform in the battery between cell to cell, then there could be a case of fire. There will be increase in temperature and increase in thermal difference, and this can lead to fire, and it was happening. So the thermal management system was very poor, and that is why the standard which was AIS, I think 48, has been changed to AIS 156, and more stringent test has come, especially in L2 category, that is for a two-wheeler battery testing, and because of which you must have noticed that now there are no fire. What was happening before a year or two, the fire has reduced, number one. Number two, there were a lot of startups who wanted to quickly make up money, and without any testing, because government is allowing up to 10 vehicles to be tested without certification for trial. So these are the vehicles which were catching fire, and now with strict norms, even they must take the approval. So if you are a startup and you want to make 10 prototypes, then for running those 10 prototypes also approval is required. Some minor tests are required, and that also is certified by organizations like GRC, ARA, and ICAT, and only then they can run. So thermal management is something which is very important, and awareness about how do you charge your vehicle. Can I charge for 8 hours continuously and charge 100%? So whether it is our mobile battery or whether it is a car charge, it is always advisable to keep the charging between 10% and 90%, and not 100% or 0%. So all these precautions and awareness is required, people who are using electric vehicle. So with proper awareness, proper education, and proper thermal management system, I think everything, and proper testing and certification, strict testing, everything is under control now. And I hope that in time to come, everything will be under control.
Thank you. Thank you, sir.
So now we are talking about the crude oil import. But when number of vehicles increasing, then we are in short of the batteries. Lithium is the biggest source, and again we'll depend on China for sourcing that. What are the strategies in the Indian government is making?
So there is a well-defined strategy to meet these requirements. Our think tank in India, which was earlier Planning Commission, is now Niti Aayog in Delhi. And Niti Aayog has studied systematically about the requirement of lithium and in India. There are certain reserves in Karnataka, Gujarat, and Kashmir about lithium, but they are not enough the rate at which we are going to use electric vehicle. And India has also taken a decision to start manufacturing cells and batteries. Right now, the cells are imported from China and Korea, and then we are just assembling it and putting it in the vehicle with BMS. However, in future, we will be making our own cell, and hence we will require lithium. So earlier, the lithium and the lithium-ion cells were coming from China. Slowly, we have shifted to Korea and Japan. And recently, not recently, last year, we signed MOU with Bolivia and Argentina, and our lithium reserve would come from Bolivia and Argentina. So this lithium would come, and then we would manufacture those cells. And then so I'm sure that all this has been done, and our move towards indigenization of batteries and motors and raw material, supply chain for raw material has been worked upon. So a very good support has come from Niti Aayog in this area. And there are associations of all this energy storage, IESA, who is also strongly working in this area to ensure that there is no shortage. But we were earlier procuring crude petroleum. Now we will be procuring lithium. It comes to one and same. The only advantage is there is no immediate emission coming out in the cities. Say by 2030, when 50% of the population would be in cities, including the smart cities, this 50% of the population must not get subjected to health hazard. So the overall pollution, that is COHC, NOx, particulate matter, and CO2 has to go down. And if we want to reduce the overall temperature, global warming, then we have to stop. We have to reduce CO2 emission drastically, and this is possible with electric vehicle. And hence, we need to move towards in this direction with all these strategies.
Thank you, sir.
Any more questions?
Dr. C.H. Sri Chaitanya to deliver a vote of thanks.
Thank you.
Thank you, sir. I take this opportunity to thank you, sir, for readily accepting to share your knowledge, and majorly on the key challenges of mobility like cost, traffic, pollution, oil imports and accidents, then solutions for those like a 10-year automotive mission plan to become third largest economy under development in line with the sustainable development goals, government initiatives like PLI scheme, national hydrogen mission, charging infrastructure and battery swapping technologies, and also your ideas on integration of mobility options, e-mobility ecosystem and future trends and trends in emerging markets, like idea of cars matching with the users, autonomous and connected vehicles with the ability to give users a relaxation, working environment and entertainment, and the technology, sensors, ADAS systems that are used in autonomous cars. Then details about the A-BAHA and H-BAHA. These will help us in guiding students to participate in various events. Thank you, sir.
Thank you very well summarized. Thank you very much, sir. And I'm also very much satisfied with all the questions which were asked in the session. Thank you to all those who asked the questions. And thank you to the organizers also.
Thank you, sir.
Thank you. Namaste. Shall I take
Thank you, sir. Thank you for delivering an amazing lecture on advancements in automobile engineering. And thank you for accepting our invitation. Thank you, sir.
Thank you. Bye-bye.